Unit 2A, Lesson 2. This lesson will align with 8.3 and 8.4 in your textbooks. There's two standards we are going to cover in this lesson. The first one, given two figures, use the definition of similarity in terms of similarity transformations to decide if they are similar. Explain using similarity transformations the meaning of similarity for triangles as the equality of all corresponding pairs of angles and the proportionality of all corresponding pairs of sides. Second standard we're going to cover, use the properties of similarity transformations to establish the angle-angle criterion for two triangles to be similar. In this first example, we're going to start with the triangle EFG and translate it and then dilate it to get triangle E prime, F prime, and G prime. If we just perform the translation, remember that's a rigid motion, so the two triangles would be congruent. But then once we perform the dilation, those two triangles can no longer be congruent, but they are still similar. So these two triangles are similar to each other. We want to find the translation rule and then find the scale factor for the dilation. Okay, so first we're going to work with the translation. Since E prime is already centered at the origin, that's going to be easiest to work with. So we need to determine what translation must we perform on E to get it to E prime. Well, our rule for XY translation is going to be, we need to move 1, 2, 3 units to the left. So it's X minus 3. And then we need to move 9 units down. So it would be Y minus 9. So that's our rule for the translation. Now for the dilation, we want to find that scale factor. Remember, we need to compare the ratio of the length of one side of our image to the length of the corresponding side of the pre-image. Easiest one to work with, since we have a horizontal line, is going to be GF and G prime F prime. So the length of our image is 1, 2, 3, 4, 5 units over, we have 6 units plus 9 more units, so 15 units, which will simplify to 1/3. So to go from our original triangle, the pre-image EFG, to get to E prime, F prime, G prime, we perform a translation X minus 3, Y minus 9, and then a dilation where our scale factor is equal to 1/3. Example 2 is going to be very similar, except we're going to be working with circles. Again, we're going to have a translation followed by a dilation. So these circles are not congruent, you can tell that right away, but all circles are similar to each other. So first we need to find the translation rule. So XY, if we're going from the center of the green circle with the coordinates X, which are 5, 7, we need to go 1, 2, 3, 4, 5, 6 units to the left. So X minus 6. And then we need to go 1, 2, 3, 4, 5, 6 units down, so Y minus 6. So that translation will take us from the center of the green circle to the center of the purple circle. Now we need to find out what the dilation would be, what this scale factor for the dilation is going to be. So we need to take the radius. It doesn't matter if you take the diameter or the radius. I'm going to take the radius of our image, which is 1, 2, 3, 4, 5, 6 units, over the radius of the pre-image, which was 1, 2 units. 6 divided by 2 simplifies down to 3. So the scale factor would be 3. That makes sense because this is an enlargement, so we know our scale factor must be greater than 1. So if we perform a translation X minus 6, Y minus 6 to get the centers of the circles to line up, and then perform a dilation with a scale factor of 3, we would get this image. Next, we're going to discuss the angle-angle similarity postulate. This says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Okay, so we don't even need to know anything about the third angles because this arises from the triangle sum theorem. We know all the angles, all three interior angles of a triangle always add up to 180 degrees. So for an example, suppose we have triangle ABC, where we know angle A is 20 degrees, angle B is 100 degrees. And we have triangle XYZ, where angle X is 20 degrees, angle Y is 100 degrees. So angle A is congruent to angle X, angle B is congruent to angle Y. This implies, because of the triangle sum theorem, all three angles add up to 180 degrees. Angle C must be 60 degrees, and angle Z must be 60 degrees. So all three pairs of angles are congruent, so these triangles would be similar to each other. We didn't need to know that information about the third angles because of the triangle sum theorem. In the final example, we're going to use the angle-angle similarity postulate to help us find the missing length M in this triangle. Some pieces of information we know about these two triangles is that angle J is congruent to angle HKG. Okay? Also, we know angle G is one of the angles in both triangles, so angle G is congruent to itself. That's the reflexive property. So we have two pairs of angles in these two triangles that are congruent to each other. So by the angle-angle similarity postulate, triangle GJI is similar to triangle GKH. So now using that information, we can find the scale factor and then use the scale factor to find the missing length. So K is going to be equal to, I'm going to use the length of the larger triangle, which is 9, and divide that by the corresponding side of the similar triangle is a length of 3. So the scale factor is 3. Now I'm going to set up another equation that we can use to solve for M. Since M is the longer length of the triangle, that's the one I started with in the numerator before, I can set up an equation where M over the corresponding side is 1.6. That must be equal to, we said the scale factor was 3. So now we just have to use some algebra. If we want to get M isolated by itself, we need to multiply both sides by 1.6. And we get M is equal to 3 times 1.6 is 4.8, and our label was feet. So using the angle-angle similarity postulate, we can find the scale factor and then use that to find the missing length. A quick review of what we talked about. For the first standard, we talked about performing translations which create congruent shapes, followed by a dilation which will create a similar shape. So performing those two transformations back to back is always going to create similar shapes. In the second standard, we discussed what the angle-angle similarity postulate was, and then use that idea to find a missing length in a triangle.